Hello, Precalculus friends. This is section 7.2 notes. Today we are going to be talking about some addition and subtraction formulas. So the first thing you're going to want to do is copy these formulas down onto your trig identities blue sheet and be very careful when you're copying them of the signs. Okay, please note when they are pluses and when they are minuses, because if you have the wrong sign, obviously when you're using these formulas, it's going to make a big difference. Okay, so basically we have the sine of the addition of two angles or subtraction of two angles, the cosine of the addition or subtraction of two angles, and the tangent of the addition or subtraction of two angles, and how we find the value of those things. So I think the easiest thing to do is just go right ahead and start looking at some of the examples. We would like to find, in example 1, the cosine of 15 degrees. And the instructions ask us to use an addition or subtraction formula to find the exact value of the expression. So what we need is two known measures on the unit circle that either add or subtract to make 15. Well, since 15 is a smaller number, I don't think we're going to find any that we know that would add to make 15, right? Because the smallest angle measure that is a known value for us on the unit circle is 30 degrees. But if we think about values in the first quadrant, what about 45 degrees and 30 degrees? 45 degrees minus 30 degrees would give us 15. Okay, so I am going to use those values as my two values that would subtract to make cosine of 15. So my first step here is going to be, I'm going to write cosine of 45 degrees minus 30 degrees, and hopefully we all agree that that equals cosine of 15 degrees. But now I'm going to go ahead and I'm going to use my cosine subtraction formula, okay? And so I'm just going to jot that down over here on the side, and this comes right off the identities. Cosine of x minus y is equal to cos x cos y plus sine x sine y, okay? That is the formula that I'm going to be using. So obviously when I'm working through this problem here, 45 degrees would be my x and 30 degrees would be my y. So the first thing I'm going to do is I'm just going to write this out. So this would be the cosine of x, so the cosine of 45 degrees, times the cosine of y, so the cosine of 30 degrees, plus the sine of x, which is 45 degrees, times the sine of y, which is 30 degrees. Now, since these are nice unit circle values that we know the cosines and sines of these values at 30 degrees and 45 degrees. The cosine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. The sine of 45 degrees is the square root of 2 over 2. And the sine of 30 degrees is 1/2. Okay, so now that we've plugged in our values for those, now we're actually just going to multiply these fractions together, straight across the top, straight across the bottom. Square root of 2 times square root of 3 is going to give me square root of 6, and 2 times 2 gives me 4. Be careful how you write that. The square root is only over the 6. Plus, square root of 2 times 1 is the square root of 2, and 2 times 2 is 4. Since we have the same denominator, we can write our answer over one denominator. So square root of 6 plus square root of 2 all over 4 will be my final answer. When we look at the next example, tangent of 19 pi over 12, it might be easier for us to work in degrees. So the first thing that I'm going to do is I'm going to take 19 pi over 12 and I'm going to change from radians to degrees. So I'm going to multiply by 180 over pi. So 19 pi over 12 times 180 over pi. My pi's are going to cancel. So then when I do some reducing, I end up with, and you can just do this right on your calculator, I end up with 285 degrees. So now my job is to find two angles that either add to make 285 or subtract to make 285. Honestly, it does not matter. It's going to work either way. But if we find two angles that add to make 285, we're going to be using our tangent addition formula. If we find two angles that subtract to make 245, we're going to be using our tangent subtraction formula. But obviously, other than that, it makes no difference. So the two angles that I selected for this problem were 330 degrees and 45 degrees. 330 minus 45 will give me 285. So that's the combination that I'm going to go with. Now, obviously, there are other combinations that would work as well, okay? So I'm going to go with tangent of 330 minus 45 degrees. All right, and I'm going to write down right here over on the side my tangent formula, just so that I have it to reference. And since I'm doing subtraction, I want to make sure that I grab the right formula. So this is going to be the tangent of x minus y is equal to tangent x minus tangent y in my numerator, and that's divided by 1 plus tan x times tan y. Okay, so that's the formula that I am going to use. Now I just start plugging things in. When I look at this equation, I'm going to be calling my 330 degrees my x and my 45 degrees my y. All right, so my first step here is going to be tangent x, which would be tangent of 330 degrees, minus tangent y, so minus tangent of 45 degrees. That's in my numerator. And that's going to be divided by 1 plus tangent x, so tangent 330 degrees times tangent y, which is tangent 45 degrees. Okay, so just a plug-in step here. And now I am going to actually plug in the values for these tangents, okay? So if you don't know your tangents by heart, it might be helpful to pull out that salmon-colored reference packet from Chapter 5 that has a table in there that has the tangents on it. That would be helpful for this. But remember, you can always find tangent. For example, tangent of 330 degrees, you go to 330 on the unit circle, you find your ordered pair, you take your y value divided by your x value, you have your tangent, okay? So tangent of 330 degrees is negative square root of 3 over 3 minus, and tangent of 45 degrees is going to be square root of 2 over 2 divided by square root of 2 over 2, so that is going to be 1. Okay, and this is divided by, things are about to get a little messy here, 1 plus, and then we already know this is negative square root of 3 over 3 times 1. All right, so I'm just going to rewrite this a little bit here, try to maybe make it a little bit smaller. So I've got negative square root of 3 over 3 minus 1. That's my numerator. And then my denominator, I've got 1 plus, and then when I multiply here, I get negative square root of 3 over 3. Okay, so the next step is, obviously, I've got radicals in the denominator of my expression. Oh, that's just not going to work. So I am going to have to multiply top and bottom by the conjugate. This is where things get messy, okay? So the conjugate to 1, it's really 1 minus the square root of 3 over 3, right? Because that is negative, is going to be 1 plus the square root of 3 over 3. So I am going to multiply top and bottom of this expression by 1 plus square root of 3 over 3 and 1 plus square root of 3 over 3. And I'm going to FOIL the numerator and I'm going to FOIL the denominator. So multiply by conjugate. These get really messy, as you can tell. Okay, so right now, I'm just going to be foiling my numerator and I'm going to be foiling my denominator. Okay? So when I do the foiling, in my numerator, I'm going to end up with the following terms. First times first, so negative square root of 3 over 3 times 1 is going to give me negative square root of 3 over 3. My outers, negative square root of 3 over 3 times positive square root of 3 over 3 is going to give me, see here, my numerator will be negative square root of 9, which comes out to be negative 3. My denominator will be 3 times 3 is 9, so I have negative 3 over 9, which becomes negative 1/3. Then I do my inners. Negative 1 times positive 1 is negative 1. And then I do my lasts. Negative 1 times square root of 3 over 3 is going to make negative square root of 3 over 3. That's my numerator. Now, hopefully you remember that when you FOIL conjugates, the whole point of that is that your inners and your outers cancel, and you shouldn't end up with any square roots when you're done. So let's make sure that that's what happens. When I FOIL here, 1 times 1 is 1. My outers would make positive square root of 3 over 3. My inners would make negative square root of 3 over 3. So those are going to cancel. So then last times last, negative square root of 3 times square root of 3 is going to give me negative 3. And then 3 times 3 gives me 9. So again, I end up with that negative 1/3 like I had in my numerator. All right, so now let's combine like terms here and try to make this look a little bit prettier. In my numerator, I've got negative square root of 3 over 3, and then I've got another negative square root of 3 over 3. So that's going to be negative 2 square roots of 3 over 3. And then negative 1/3 minus 1. If I think of negative 1 as being negative 3/3, that's going to make negative 4/3. And then in my denominator, 1 minus 1/3, that gives me 2/3. All right, I am almost there. My next step here is going to be to keep switch flip. I am going to multiply the numerator by the reciprocal of the denominator. So that's going to look like this. Negative 2 square roots of 3 over 3 minus 4 over 3. And that's all going to be times 3 over 2. Okay, now when I do that, multiply everything by 3 over 2. First of all, the 3 here in the numerator is going to cancel the 3's in the denominator. So then I'm going to end up with negative 2 square roots of 3 minus 4 all over 2. Sorry, I don't want to confuse that with that. And that can be simplified a little bit. That's what I would call a love connection. Remember, I warned you this was going to be tedious, right? So both of these terms can get divided by 2. So negative 2 square root of 3 divided by 2 just makes negative square root of 3. And negative 4 divided by 2 makes negative 2. Whew, that was a lot of work, my friends. Very messy. The tangent examples are always very messy.